Welcome to sine wave questions, how time correlates with alternating current sine waves. Number one, if a frequency has one cycle every 1/60th of a second, what is that frequency? And of course, if it has one cycle every 1/60th of a second, then that means it has 60 cycles every second. So of course that frequency would be 60 hertz or 60 cycles. So in other words, because there's one cycle in every 1/60th of a second, now if we have 1 second, we just have 60 cycles. I called it 60 cycle because this frequency is called 60 cycle. Okay, so there's the answer. And now number two, 30 degrees of a phase is what of a cycle when using alternating current? And it's asking how much of the cycle. So what fraction? So if we look over on the very bottom right, we see that picture of the sine wave. You won't find this picture online. I actually made this picture and you can download it. There will be a link in the description that will take you to my Google Drive where you will find a downloadable link for that picture along with the graph next to it, which correlates with it. It's all one picture. And then you'll also be able to find a downloadable version of the questions as well if you want to find that. Okay, so looking at the sine wave, we see that it is 360 degrees and we also see these 30-degree increments. So if we had one of those 30-degree increments and we wanted to think of a fraction of a number, what would that number be of the entire 360-degree cycle? And because one cycle is 360 degrees, then that is the whole cycle that we're working with. All we have to do now is divide 30 degrees from this 360 degrees to find out what number this would be of 360 degrees. Of course, you could also turn that fraction to a decimal point, and then from there you could also find out that number, and then you could also figure out the percentage of the relationship of 30 degrees to 360. But for now, we're just going to find a fraction. So we're just going to do 360 divided by 30, and these are the degrees. And like I say, even if it's simple, it's good to always use a calculator. So 360 divided by 30, we see we get 12. Okay, and remember this is giving us a fraction, so this isn't 12, this is actually 1/12, because 12 is a part of the 360. We have 1/12 of the 360 degrees when we have 30. Now this becomes obvious when we do 30 times 12, because we're just thinking about, okay, we have 30 degrees, that was 1/12. So if we do times 12, we get 360. Therefore, again, that picture on the right there, when we're thinking about one of those increments, any of them, in this case, we're thinking about 30 degrees. All we have to do is think 360 divided by 30 degrees. We see we get 12, but that just means that 30 degrees is 1/12 of a section of 360 degrees. Okay, and when you divide a number by another number, you get the percent. So if we had a 100-question test and we got 75 correct, we'd have 75%. Of course, if we only got 25 correct, then we'd have 25%. The reason why I'm showing this is because we can do 1 divided by 12. Then we have about 8%, or if we want to leave those decimals in there and we're thinking about percent, we'd have 8.33%. Okay, but in this case, this is the answer we're looking for, 1/12 of a cycle. But now you know if the answer had a option that also said 8.33%, then you would know that that would actually be the answer if you didn't see 1/12 of a cycle, because it would still be 8.33% of a cycle. Okay, so before moving on to number 3, let's just note that in number 2, we didn't see anything indicating we're working with 60 hertz or 60 cycle frequency, but instead we just saw the fact that we're using alternating current. Okay, so we have to know that here in America, we use a 60 cycle frequency. If you're in a different country, then you're going to have to know what that is. It might be something slightly different. So you can see it doesn't always state that we're using the 60 cycle frequency or 60 hertz frequency. Okay, so question number 3, a 60 cycle frequency takes how many seconds to travel 180 degrees? Okay, so 180 degrees. As we see again on the graph on the bottom right, 180 degrees is just halfway through one cycle. As we remember from the very first question, one of these cycles happens every 1/60th of a second. In other words, this happens 60 times a second, and that is 360 degrees. So if we just take half of that, we're no longer working with 1/60th of a second, but now we're working with double that. So we're working with 1/120th of a second, but let's solve and actually use an equation if we're using a more complicated number, something that would come in handy. Okay, so now a simple method of doing this is we could just think what percentage of 180 is 360. So again, to do that, you just would get 180 degrees. And you say, I want to find out what percentage 180 degrees is of 360 degrees. And of course, most of us probably can do this in our head. We know it's 50%, but the point of this is to use simple numbers to start, so then we can use more complex numbers further on, and we can grasp it really understandably and not have any problems. Okay, so 180 degrees divided by 360 degrees would mean that we would have 50%. So I just did 0.50 just to show that it's 50%. And remember, there are 60 cycles in every second. So now that we have the percentage taken from what happens in 1/60th of a second, now we still need to think about the fact that we have 60 cycles. So now we need to take 60 of our cycles and we need to divide that by a percentage of 0.5, 50%. Okay, so 60 divided by that 50%, we can see we get 120. But in fact, 120 is not our answer. 120 is the part of the answer. In fact, this is 1/120th of a second. This might seem kind of odd doing this at first, so we have a few more to really wrap our head around this. Okay, so number 4, how much time does it take a 60 cycle system to now go 90 degrees? Of course, now that we comprehended the last question, this one should be pretty easy. But now let's make use of those formulas and actually solve this. It's good to always double check things, so we could first try to solve it in our head. If this is too much, I'm just going to briefly go over this, so don't worry. We think a 60 cycle frequency. Okay, so there's a cycle every 1/60th of a second, like the first question. And then the last one, we went 180 degrees. So we saw that went from 1/60th of a second to 1/20th of a second. We're working with those fractions. Well, now if we think 180 degrees and we think 90 degrees, well, that's just half of 180 degrees. Just like 180 degrees was half of 360 degrees. So we're working with another half. If we think of that same mindset, we just think, okay, what happened before? We got 60, basically doubled that number. We got 120 was 1/20th of a second now. So same thing. If we just take 1/20th of a second and we think, okay, we're getting half smaller now. Now that fraction, that bottom number, the denominator is going to multiply by 2 again. So we're going to see the 120 just turns into 240. Now we have 1/240th of a second. So now let's actually solve for it. And remember, to get a percentage of something, you're just going to be taking that smaller number and you're going to be dividing it by the whole number. So like on a test of 100 questions, you got 75 right. 75 is the smaller number. You divide that by the whole number of questions, which is the 100 questions. And you just get 0.75, 75%. So now again, we're just going to think 90 degrees is what percent of 360 degrees? And to do that, we're just going to divide 90 degrees by 360 degrees. If you know your degrees and the circle really well, this one's pretty obvious if you think about it. But again, we're just starting with simple numbers. So we take 90, we get divided by 360, and we get 0.25. This is pretty obvious when you think about it, because when you think about it, 360, and then you think about 180, okay, that's half, and 90 is half of that. So a quarter, just like 0.25. So very easy just to think about that one in your head as well. Okay, so we have 0.25. Okay, so I like to circle it when it's not a final answer, but it's still important. So now we know that 90 is 25% of 360, but we're working with a 60 cycle system. And remember, we want to know how much time it takes the 60 cycle system to go 90 degrees. So in this case, all we have to do is keep in mind of the 60 cycle system, and we just get 60 and we divide it by the 25% as a decimal point, which is 0.25. 60 divided by that 25%, we get the number 240. Okay, so we have 240, but we need to remember that 240 is just a part of what's going on here. We actually have 1/240th of a second. Okay, so I double box that one. And again, with the explanation from us thinking about it in our head from the beginning, we could see, well, this is actually pretty obvious here. It's good to actually make sense of these things and not just figure out how to solve for them. Because if you just figure out how to solve for them, you're going to forget about that really quickly. If you understand how to solve for it, then you can remember and remind yourself again, okay, how do I solve for this again? And you can just make sense of it. Okay, so before moving on to number 5, let's just take a look at that graph again at the bottom right and see that when we're at 90 degrees, we're just halfway between 0 and 180. And also 180 is just halfway between 0 and 360. So obviously, if we think about fractions, 180 would just be 1/2. And then 90 would just be 1/4. So we could think about that the same way, 0.25, and we can think 60 cycles divided by 0.25, but if that's a little weird, then just think about it like this. You have 1/60th of a second, and just think about your bottom number changing here. So remember, if we had 1/60th of a second, and that occurred for a period of time, if we took twice as slow as that, then just think of that number on the bottom multiplying by 2, we'd have 120 now. Okay, but if instead of that, we think, okay, this is going to be 4 times slower, just think times 4, and you could see that you get the number 240, and then just think you have 1/240 now. So if all the dividing by the percentage seems a little complicated, just think instead of fractions. Just like this, you had 1/60th of a second, and now you had 1/4 of that, so just multiply those. Of course, 1 just turns into 1, and 240 is 60 times 4. So you could just also think purely in fractions. Okay, again, we had 1/60th of a second, and we're just thinking 1/4 of that, so we could just multiply both those fractions and get 1/240th of a second. So you see, there's multiple ways to solve and to comprehend this depending on how you want to think about this. Okay, so we'll use that fraction method for this next one, number 5. Okay, so things got a little messy. Now we're on a fresh page. Number 5. How much time does it take a 60 cycle system to go 270 degrees? Okay, now we can't think of the last answer to rely on any information for this. No, we got to think all fresh now. Okay, so again, we have 360 degrees, and we want to think of the amount of time it takes a 60 cycle system to go 270 degrees. 360 degrees of a cycle happens 1/60th of a second. So let's just write that down. We'll think 1/60th of a second is what we're working with. And we're thinking, okay, so now we have 270 degrees. You can think about 180 plus 90, that's 270. Okay, so we have a halfway point plus another quarter, so we have 3/4. You could also look at the graph again at the bottom right. 90 is 1/4, 180 would be 1/2, so that's 2/4, and then 270 would be 3/4. And then again, if we had another 90, we'd have 364 quarters, so a whole. Okay, so now let's do this. We have 3/4, and we're just going to multiply these numbers. Okay, you can see this one turned out a little weird here, but this is if the fraction just makes more sense to you. So we're also going to solve it the original way after this. So we see we get 3/240, and now we want to make this 1 over something. So all we got to do is divide all this by 3. So we divide the top by 3, we divide the bottom by 3. I'm going to put everything over here. Okay, so 3 divided by 3, we obviously just have 1. And then 240 divided by 3, we have the number 80. So that shows us that we have 1/80th of a second as our answer. And as you see, we ended with the actual decimal of 1/80th. So now we don't have to have a number 80 and then think, okay, we have to do 1/80. We actually ended with the actual answer using this method. Okay, so there's the fraction method. Now, if the percentage method made some more sense to you, let's think about that. So 270 degrees would be what percent of 360 degrees? And that would be 0.75. And of course, we can make sense that this is 0.75 pretty obvious, because before we just thought about the sine wave graph and how if we thought about a fraction, this is 3/4. So 3/4 and 0.75, those are the exact same thing. So everything's looking good here. And now we're thinking about a 60 cycle system, remember? So now we just think 60 of those cycles. Okay, so now we get 60 cycles, and we divide it by that 75% of the entire sine wave. And we see because of that, we get the number 80, which then we turn that into 1/80th of a second. So we see here, we didn't end with 1/80th, we actually ended with 80, and then we had to turn that into 1/80th of a second. So no matter which method you find easier, we have 2 different methods there. The percentage one, just saying, okay, so we have a certain number of 360, so what percentage is that number of 360? We get that number, and then we think a 60 cycle system, and then we just think 60 divided by that percentage, and we get our number. And then we just put 1 over that, and that tells us what fraction of a second this occurs. And then the other one is just staying with the fractions and thinking about the sine wave. Think about the fraction of a single sine wave cycle, so 1/60th of a second. And then the other fraction that just tells you how much of the whole sine wave you're working with. So because the whole sine wave's 360 degrees, we would think that would just be 1 whole, and 270 degrees is just 3/4. So again, we just multiply those two fractions together, and then we want 1 over something because we want to know this occurs in how many seconds. And to make it convenient, we're not going to think we want 3/240ths of a second. We want the answer to be 1/80th of a second, which we could also turn into a percentage if we wanted to. But the whole point is we want 1 over something. So we had 3 over 240. We just divided by 3 and we got 1 over 80. So 2 different methods there. And then that leads us to the fact that we could do 1 over 80 and find out what percentage of a second this occurs in. So 1 over 80. So that's it for this video. If you had any questions or maybe even comments, feel free to leave those in the comments below. I'll answer them to my best ability. If you want to email me, just email me at the email shown right here. Give the video a thumbs up if you enjoyed it. This will help other people to see it as well. And if you want to keep seeing more videos, make sure you subscribe. I'm going to have a lot more videos coming out. We're going to be looking at some more things of how the sine wave correlates with electricity. We're going to look at the unit circle and understand trigonometry equations a little more, as well as a lot of other things. If you didn't see it, I just had a video about 3-phase power explained. It's about an hour-long video breaking down the sine waves, the difference between single phase and 3-phase. It even throws in the difference between DC and AC a little bit in there. We have a visual look at sine waves, and we understand equations that differentiate Y and delta configurations for alternators. Before that, I have a video understanding the difference between parallel circuits, and another video about when you have a mixed circuit containing series and parallel resistors. How do you math everything out? How do you make sense of that? So I already have a video about those things. Make sure you check those out. Those will be linked in the description below. And that's it for this episode. So until next time, take care and goodbye.